So here we're going to review some properties of simplifying radical expressions, but just in the context of functions now. So if we have this function, which is the square root of 4x minus 4, and we want to find f of 5, then how we would approach this is just like we did with previous functions where we're taking a square root, and I have 4 times my input minus 4. And in this case, the input is going to be that value of 5. And then we're going to simplify. So square root of 20 minus 4, which is the square root of 16, which is a positive 4. Now, something I want to revisit that we talked about with radical expressions, but I'll talk about again, is this idea of the principal square root. A common mistake that happens here is that we get used to this idea of plus or minus 4. However, with this, we are simplifying an expression, really. So as we're simplifying, we use the principal. And that is because we are simplifying an expression. Where the plus or minus comes in is when we're solving an equation. So if we were solving that x equals, or sorry, let's go with x squared equals 16. The idea here is that we are solving for all possible values of x. So in that solving process, we take the square root of both sides. And if I want all possible values of x, then I get the plus or minus because I want to see all possibilities. But simplifying an expression, we're just using the principal. So just be careful of those two scenarios. Okay, let's say we want to find f of 0. So f of 0, sorry, I was writing f of x for all of those. I should be writing f of 5. Let's get that notation right here. F of 5, f of 5, 4. Okay, f of 0, square root 4 times input minus 4, and we are plugging in 0. And as we simplify this, we're going to have 0 minus 4. So we have a square root of negative 4, which cannot happen. We can't take the square root of a negative. So with this, it is undefined, or not a real number. Okay. If we want to solve, we're going to go 2 equals our function, which is the square root of 4x minus 4. Now this is the scenario I was talking about up above, that if it comes down to it, we might bring through a plus or minus just based on wanting all possible solutions. Don't think it'll happen in this case, but good to keep it in mind. So I'm going to square both sides so I can get rid of that square root. So we're going to have 4 equals 4x minus 4, lots of 4s. Add 4 to both sides, divide by 4, and we're going to get an x equals 2. And with solving our radical and rational equations, we always want to check that we didn't get an extraneous solution. So to check it, we're taking the square root of 4 times 2 minus 4. So that's an 8 minus 4, which is in fact a positive 2. So we're all good there. Okay, finding average rate of change. So this is where we're going to take the difference in outputs. So f of 3 minus f of 1 over 3 minus 1. So we're taking the square root of 4 times 3 minus 4 minus the square root of 4 times 1 minus 4 all over 3 minus 1, which is a 2. And let's see what we get out here. So square root of 12 minus 4 is an 8, minus the square root of 4 minus 4, which is a 0. And simplifying that down, we're going to simplify our square root of 8, so that's the same thing as the square root of 4 times 2. So we'll have a 2 root 2 minus 0, we can get rid of that, divided by 2. Cancel those 2's outside of the radical, and we're going to be left with root 2 for our average rate of change. Okay, let's do some more examples here, but here we're going to see a cube root. So g of negative 2, we're taking the cube root Again, wherever I see x, I like to throw an empty parenthesis so I can see the structure of my function. And then we're plugging in a -2. So this is going to be the cube root of 4 minus 4, which is the cube root of 0, which will give us a 0 in the end. All right, what if we plug in 6? So g of 6 is the cube root of 6 squared minus 4. So the cube root of 36 minus 4 for 32. And let's see what we have here. You know, when I start stumbling, I just start breaking it down into the prime factorization. It's like 32 is made up of a 2 and a 16, which is made up of a 2 and 8, which is made up of a 2 and 4, which is made up of a 2 and 2. So let's see, we have a combination of 1, 2, 3, 4, 5 2's multiplying with each other. And to get anything to come out of there, we need a grouping of 3 because it's a cube root. So what we can do is group 3 of these to bring a 2 out front, and then I'll have a cube root, and I still have a 2 times 2 trapped underneath. So those are stuck. So with that, we'll still have 4 underneath that cube root. Okay, what if we wanted to solve? So we're going to have 3 equals the cube root x squared minus 4. Let's go ahead and cube both sides so we can get rid of that radical. So we have 27 equals x squared minus 4. Add 4 to both sides, so 31 equals x squared. Now we're going to take the square root of both sides, and this is the case where plus or minus is going to come in. So we're solving for all possible values of x, and when we take that square root, we have a plus or minus, and then just a square root of 31. Okay, last one here, finding the average rate of change. So we're going to take f of 4 minus f of -2 over 4 minus -2. So we're taking a cube root of 4 squared minus 4 minus the cube root of -2 squared minus 4 all over 4 plus 2, which is 6. Okay, so that's going to be a cube root of 16 minus 4, so cube root of 12, minus 4 minus 4 is 0, so that's just going to turn to 0 over 6. And that cube root of 12 won't simplify. Again, you could think about that prime factorization, but we won't have any groupings of a triplet. We won't have 3 of a kind. So with that, nothing to bring out, so we'll just have cube root of 12 divided by a positive 6. Okay, so some math and calculations that we've done before, but now we're looking at our function notation, as well as these calculations for average rate of change.